is Martin, who's an AI expert at Gamechuck. He's an industry professional with many years of experience in game development, ranging from mobile games to PC and console gaming. He's currently working on Midwintar, which is a cross-platform multiplayer AI-driven game with complex behavior trees controlling the NPC behaviors. The title of his presentation is Ups and Downs of Using Behavioral Trees in Unity to Model Villager AI. Okay, so the floor is yours. Thank you.
Thank you very much. Pleased to see you in such number here. I didn't quite expect that. As presented, I work in Gamechuck on Midwintar project, and here I am using that example to to present better the AI, what it means once it's inside of game. So to tell a little bit about my company, we are a video game and hardware developer. We are established in 2017, based in Zagreb, Croatia. We do like retro-style action games and large-scale narrative-driven adventure games. Example of adventure would be the Midwintar announced project and Speed Limit, which is also pixel art cross-genre game. While we also do have Professor Baltazar in work, which is more narrative-driven, point-and-click, and Arc the Trip Fantastic, and so on. The company has been awarded sometimes and has many nominations for numerous different awards across Europe. And about me, I don't have any official diploma in the field or anything. I just bothered too many people who were willing to share any kind of knowledge, asking, got sponsored for some courses and so on. Been creating games for mobile phones, all the current consoles, PCs, everything, proficient in Unity, while also knowing C++, Unreal Engine, various kind of knowledge. And for this specific topic, while I do have general knowledge, kind of jack of all trades style, my main forte is performance of the game and the in-game AI. About the project I'm working on, it is narrative-driven stealth action inspired by medieval folklore, horror, and different play modes are in mind for the game. And from players, it is expected to combine careful tactical planning using resources, whether it's from the selected character they have or to use what is ever put in the level design to make the goals work, like multiple ways to accomplish it, but there is a singular goal for each and every level. So we have variety of playable characters, there are different tools, one goal, and villagers who, even if you are working for them in a kind of way, they are usually hostile towards those playable monstrous characters player take. So this game quite heavily relies on NPCs to make it fun, to make it immersive, to adapt to every situation player can create in that specific level, in that specific world. And NPC, to define it, is non-playable character or any character in the game that is not controlled by player or anything. They are driven by behavior trees, sometimes state machines, or different kinds to achieve wanted behavior. They are used to fill the world, to make it more immersive and everything. So in this regard, we are abusing those NPCs to fulfill the game Midwintar, each and every level. So what is game AI? That is quite different from the academic definition of AI. Here we want different things usually known before everything is compiled, published, And here we have to define what does the NPC do regularly, like here doing his job, or different videos. Seems kind of static now. How they react to suspicious things over here. The door is broken on their house, someone will spot it, and so on. While still performing their duties, and we need to accomplish something to encompass all those different scenarios and make it interesting for player. Just a second. All right. So what is with this specific goal? A little bit slower. All right. Bit unresponsive, I apologize. So first thing with NPC, in-game AI, is the issue of technical limitations of the device the game is being ran on. Because players do want that, last presentation, FPS term came up, they want those 60 frames per second. So that gives us maximum time on the main CPU thread for processing all the data in between the frames, at most 16.6 milliseconds, and wishfully even more, wishfully even less time. So that number wouldn't provoke them, because even for one longer frame, one frame drop will ruin the immersion, player will feel it, and that is something we want to avoid completely. So to define such villagers, we most commonly use in game development behavior trees, which is hierarchical, just tree graph presented which defines the order of the execution of certain actions, conditions, branching, and everything graphically put so anyone can put one together, whether it be programmers, designers, whoever. And they usually look something like this, some nodes which names are telling everything. And for example, this one runs a sequence, get a random position, move there, and wait for a certain amount of time. To create behavior trees, we have two main node types. Those would be action or execution. They are basically leaf of the tree, the endpoint. You cannot go from there anywhere else. And usually it does some kind of action, like in previous example says the destination checks if it reached it, kind of combination of condition and the action itself. While on the other hand, we have composite or control nodes. They further control branching, everything in between to lead to an action we want to accomplish specifically. Also, we can create condition nodes either as an action which will block the execution of previous composite, or the decorators which can modify the return value of everything in that branch below it. For example, that repeat will modify the return value and put it back to execution of its children nodes. And each node will return a value when it is reached by the tree, and it is either success, which means job or action is completed, failure, it is blocked, it is impossible to do it, or running, which means that the current action is currently in progress because everything is real time, everything is executing while the player is playing the game. So that is the in-between state, but not basically in between those two, but until one of those are reached. Here is an example for a more complex behavior tree. So basically, the interrupter is basically a selector, which selects based on the given data, what should that villager do. That is part of a subtree. So this NPC's goal is to get the firewood from the box, put it into stove, stoke fire, and repeat until other job is given to him. But the order of execution is first does he have firewood in his hands? If so, go to the stove, play the animation to stoke fire, do all the background checks and events to give light to that stove and everything. If he doesn't, he checks, does he see in his sight, maybe he's stepping across the firewood. If so, he will pick it up. If not, he will go to the first box, which stores it, and grab one and do his job properly until interrupted by something bigger, like a player influence. And also here is an example for more complex part of the tree. And usually we can see it real-time executing. Like these yellow frames means that the branch its children are currently running, because everything is returning value back up to the root of the tree. And for example, here we have a green border, which means that job succeeded in its execution and moving up to next. Or we have red one, which means that that specific branch failed, and depending on the parent nodes, it will do and trigger different behavior. So when we create a behavior tree, we always start from a unique node, which is root node. You could see it always on the top. It had a red label upon it. And it always goes from top to bottom, from left to right. And that way, we actually organize basically like visual if-else statements. And we use it to create more complex, more lifelike creatures, while still keeping a certain distance from true lifelike to better up the immersion of the game. And that graph serves to easily manage it, and we can even put the graph together through a code, depending on the needs, however we actually like, and however is the agreement between the game designer and programmers, of course. And yeah, can be dynamically placed, mixed and matched. Anything is basically possible. And here is the example of one. So on the top picture, we have a common part of behavior tree, which is common for every NPC. All are doing that part of the tree. And on the most far right, we have behavior runner. That's how we called it. And when the NPC spawns, it takes the data, what are his jobs, how will he respond to player and everything. And on the loading screen, it populates the data beneath it, like on the bottom picture. So we don't have cluttered. This is still cluttered tree, but it could be worse, and this way we can manage and easily debug it and see what's going on without too wide tree. And the main problem with behavior trees is performance. I mean, with AI, any kind of AI in game is performance, because of that limit for the execution, for all the calculations we have. They are usually heavy on the CPU, if it's PC or main thread specifically, and multi-threading in game development is sometimes a no-go, and there are many restrictions, race conditions, etc. And we have to take care of it. So we also have to optimize such tree, such system as well. So first and foremost, of course, as trees are updated, looking for data, how to sort it, and so on. we have to avoid heavy functions. Those who work in Unity might know prime example of it, like get component or something that is searching a large subset of data. Or those need to be avoided, of course. Also, we don't want to have tree sometimes on update itself. We want to trigger it manually, all those checks, so we can have better control and avoid anything unnecessary when manually searching for it, triggering it. And of course, multi-threading can be done, but it comes with its own risks and dangers. And if it's still too heavy, we have to separate them to have more control over when to trigger them. For example, we don't have to update them every frame. We can call them in intervals, set them in groups. So group 1 goes on the first frame, group 2 goes to the second frame. We have to divide that processing power across the multiple frames, and that's the easiest way to accomplish such performance gain. Also, we can set different priorities, because those NPCs in camera frustrum are more important than those outside the view, so they can be updated less frequently. Or some NPCs like farm animals or anything are more decorative, so they don't have to act so snappy. But with such performance gains comes an issue that NPCs are stuttering. And basically what we have to do here is we collect data in X amount of frames, while interpolating that visuals across every frame. We have one frame, every frame is a visual update, but data collecting, decision making, everything is gathered in intervals, and just make it smooth, like usually in game development it is, fake it till you make it. And for behavior trees as a system, there are different things we as developers, as people who are interested or anything can do, can go for known performance gains, like flat stack approach towards checking all those conditions, interrupters. We can also modify, that includes the designers and everyone, the tree to be deep enough not to check 50 different things every frame and every update, actually. So in that way we can optimize it basically, but we also have to, as the project goes on, it usually takes a while, reiterate, revisit those scripts, revisit those trees, see what can be gained, anything to make it better, constant improvement. And it will allow us to spot any bottlenecks and everything. And what I want to suggest in general, it is an open system. Everybody knows about it, of course. What we need is to discuss such topics, share opinions about it, whether it be online or on meetings or anywhere. Basically, how to improve, how to include more flexibility, how to include more data calculations into all those things to make it more advanced, improved, and interesting for a player. Yeah. So, to sum it up, AI in video game is not academic AI. Different goals. In game we have expected behaviors, what we want. It is all statically, basically, because we need to debug it, we need to run it oftenly, and so on. So it strays quite away from academic definition of AI. And behavior tree is basically a compact visual way anyone can create one once programmers create actions and conditions and everything. Graphical user interface makes it easy for anybody basically, and that's how we manage the AI in video games. Thank you very much, and if you have any questions, now would be the time. Thank you.
Hi, thank you for your talk. It was very interesting. So a quick question. So when you say AI is not academic AI, does it mean like all your processes are deterministic, like in these behavior trees? So they are hard-coded.
Basically, yes.
So why is it so? Why don't you just use the data and learn from like the past? And
Programmers usually don't have such a... sorry.
Mm-hmm.
Sorry.
Yeah, I mean, it seems like very redundant to have so many kind of, if from one interrupter you have so many kind of branches. So wouldn't it be easier to just have one calculation in place that is AI calculation?
First and foremost issue is the performance. Average consumer PC couldn't handle such calculations to be adaptive and true meaning of AI. While on the other hand, personally I can say this is much easier to debug because I know what to expect from the game, but it's mostly technical current limitation. Future might be welcoming towards improvements like tensor cores on NVIDIA and such systems where they have dedicated chips for such calculations, but currently it is out of question when aiming for the broader audience. Welcome.
Do we have any more questions?
Yeah, so just a quick one. So is your process, does it have any stochasticity in it at all, or everything is deterministic? Meaning, like, do you allow for random behaviors?
Sorry, I didn't hear.
So at the stage of interrupter, is everything deterministic? Is there any randomness in it?
There is randomness, yes, but we use basic RNG for little tweaks. So every play of every rerun of a level won't be the same. They will go to different spots and everything, but it is mostly deterministic.
Hi. Have you tried any alternative approaches to behavior trees for game AI?
I did try with state machines, and actually first attempt was, before I knew about that those things exist, hard coding and writing everything down in code. So pretty hardcore low-level approach, but yes, beyond those three, I didn't try anything else so far. Seems to be all. Thank you very much.